In the world of software architecture, we've reached a breaking point. For decades, we relied on simple message queues to pass data between services. But as our apps grew, our systems started to choke. Today, real-time isn't just a feature, it's a requirement. Welcome back to Topictrick. Today, we're diving deep into a battle of architectures, Kafka versus traditional messaging. We'll explore why the biggest tech giants on the planet have ditched traditional queues for durable event streams, and more importantly, we'll help you decide which one is right for your next project. Let's get started. First, we have to talk about the why. Why do traditional messaging systems, things like RabbitMQ or standard JMS, start to break? It usually happens when traffic spikes. Imagine a massive sale on an e-commerce site. Suddenly, your queues pile up, your consumers can't keep up, and everything turns chaotic. We call these system failure points. There are three big culprits here. 1. Disappearing data. In many old-school setups, once a message is consumed, it's gone. If your service crashes mid-processing, that data is often lost forever. 2. Tight coupling. Producers have to know too much about who is listening. Adding a new feature often means rewriting the producer or duplicating entire queues. It's a maintenance nightmare. 3. Scaling gravity. Scaling feels like you're fighting gravity. You add more brokers, then more consumers, then complex coordination logic, until the whole system becomes too fragile to move. Before we define the solution, let's define the limit. Traditional messaging systems were built for a simple time. Think back to the era when we just needed to send an email or resize an image in the background. A queue's job is to be empty. It's a fire-and-forget model. You send a command, it gets processed once, and it's deleted. This works for simple task queues, but modern systems are data-heavy. We don't just need to process a task. We need to stream events, feed multiple downstream services like analytics and search simultaneously, and this is the big one: replay history when things break. Traditional brokers struggle because they were never meant to be storage engines. So what is Apache Kafka? Put simply, Kafka is a distributed event streaming platform designed to handle high-volume, real-time data feeds. Unlike a queue, Kafka's core architecture is built around the log. Think of it like a DVR for your data. 1. It's an append-only event log. Events are ordered by time and they are immutable. Like a database commit log, history cannot be rewritten. 2. Events are persistent. Consumers don't remove messages. Data stays there for a day, a week, or forever, depending on how you configure it. 3. Decoupled consumption. This is the game changer. One event can power 10 different services. A slow analytics job in the back won't block your high-priority notification service. As we say in the industry, one event, many consumers, zero contention. When you adopt Kafka, it stops being just another tool and becomes your system backbone. It acts as the central nervous system connecting your microservices, your databases, and your analytics. It offers 3 superpowers. First, loose coupling. Producers just emit events. They don't care who's listening. Want to add a new fraud detection service? Just subscribe it to the stream. No upstream changes required. Second, time travel. Because the data is durable, you can rewind your offsets. You can replay the last 24 hours of data to fix a bug or train a new machine learning model on past events. Third, horizontal scale. Need more power? Just add more partitions and brokers. Kafka distributes the load automatically across the cluster. Now, why do ops teams love Kafka? Because it's built for operational excellence. When you're running at scale, you need to sleep soundly at night. Kafka gives you fault tolerance. Your data is typically replicated 3 times across different servers. If one broker fails, you don't lose data and you don't go down. Beyond that, you have a massive ecosystem. Kafka Connect for no-code integrations with Postgres or S3. Kafka Streams and Flink for real-time processing, like windowing and joins. Schema Registry to ensure bad data doesn't break your consumers. It's a mature, battle-tested environment. But hold on, Kafka isn't a silver bullet. It's a powerful tool, but it's also complex. You need to choose the right tool for the job. Kafka becomes the preferred option if you have high-volume streams, like clickstreams or sensor data. You have multiple consumers needing the same data. You need data auditability and the ability to replay history. Stick with a traditional MQ, like RabbitMQ if you're doing simple background jobs, like sending a single email. Your traffic is low and predictable. You need complex, native routing logic like topic exchanges that Kafka handles differ. Fundamentally, the move from messaging to streaming is a mindset shift. We're moving from transient tasks to durable data. Remember the core difference. Traditional messaging moves tasks. Kafka moves data. Don't over-engineer your system if a simple queue will do. But if data is the lifeblood of your architecture, Kafka is the infrastructure that will let you scale without breaking. We hope this deep dive into Kafka versus traditional messaging helped clear up the confusion. If you're already using Kafka, or if you're trying to decide if it's the right fit for your team, let us know in the comments below. If you enjoyed this architecture breakdown, hit that subscribe button and give us a thumbs up. It really helps the Topictrick algorithm find more engineers like you. Thanks for tuning in. Don't forget to check out our channel for more deep dives. See you in the next episode. Happy learning!